Okay, we are going to start off with the next question. Uh, in the previous video, we have done up till question number 6. Now we are going to start with question number 5. We have already done. We'll do question number 6, which is from October November 2011. Paper 1-3. Question number 7, the question says that a straight line passes through the point and the gradient is given to you. The question is not directly related to quadratics, but it is related to coordinate geometry. The equation of a line is y minus y1 equals m into x minus x1. We just need to substitute the values of the coordinates in place of x1, y1, and m is already the gradient that is given, so the value of y1 is 0 and the gradient is m x minus 2. So if I simplify, it is going to be y equals to mx minus 2m. Let's move forward. The second part says that find the two values of m for which the line is tangent to the curve, which means that the line and the curve, they both are intersecting each other, but they are not basically intersecting, they are just tangent, which means that there is just one point of intersection. For which value of m, find the coordinates of the point where the line touches the curve. Let's first of all solve the first portion of the graph, which says that the line and the curve, they are tangent to each other, which means that b square minus 4ac is equal to 0. So we know that we are going to solve both the curve and the line simultaneously. We are going to put them both equal to each other. The equation is mx minus 2m, and it is equal to x square minus 4x plus 5. We'll simplify x square minus 4x minus mx plus 5 plus 2m, it is equal to 0. We know that the coefficients are 1, the coefficients are minus 4 minus m, and the value of c is 5 plus 2m. Now if we simplify them, if you further simplify, it says that the tangent and the curve, the line and the curve, they are tangent to each other, so it means that b square minus 4ac, it is equal to 0. Let's substitute the value of b, which is minus 4 minus m whole square minus 4 times 1 times 5 plus 2m, it is equal to 0. It will be 16 plus 8m plus m square minus 20 minus 8m, it is equal to 0, which will become m square. 8m and 8m will simplify, and we will be left with 16 minus 20. It will be minus 4 equal to 0. We can factorize it, m minus 2 and m plus 2, it is equal to 0. We are going to put both of them equal to 0 separately, and they will give us two values of m, one as positive 2 and the other one as negative 2. Yeah, we have found for each value of we have found the value of m. This was the first portion of the question. The second portion of the question says that for each value of m, find the coordinates of the point where the line touches the curve. So we need to substitute each value of m into the equation, into this equation. Let me label this equation as equation number 1. We have found two values of m. We are going to substitute both values of m over here one by one, and we'll find the coordinates where the line touches the curve. For the value of m being positive 2, it will be x square minus 4 minus 2, which will make it minus 6x, plus 5 plus 4 9, and it will be equal to 0. X square minus 3x minus 3x plus 9 equal to 0. If I simplify, it will be x x minus 3, it is equal to 0. So from here we can have one value of x, which will be 3. So for this is one value of x that we have found from where the value of m is positive 2. And if the value of m is minus 2, let me substitute the value of m as minus 2. It is going to become x square. I'll substitute that again in the first equation, the equation that I have labeled as 1. So it will be x square minus 4 plus 2 is be minus 2x plus 5 minus 4 will be minus 1, plus 5 minus 4 plus 1. So if I factorize it, it will be minus x plus 1 equal to 0. If I do the factorization, x minus 1, x minus 1. So if I simplify, I will have the value of x as 1. So these are the two values of x where the line and the curve, they can be tangent to each other. So we are going to substitute these values into the any of the above equation. For example, if I substitute into the y equals to x square minus 4x plus 5, if I substitute 3 in it, it will be y equals to 9 minus 12 plus 5. So 9, it will be 2, it will be positive 2. The value of y is positive 2. Similarly, if I substitute the value of y as x as 1 in the again curve equation, it will be 1 minus 4 plus 5, which will be again 2. So if I write down the coordinates of the points, let me write the coordinates over here on the left side. One coordinate will be 3, 2, and the other coordinate is going to be 1, 2. Let's move forward. In the next part, it says express this is the standard form, and he is asking you to express the standard form in completing square method. So let's do it. That's the same methodology that we are going to use. We already have done a couple of questions earlier as well. So the coefficient of x square is already 1, so there is no need of taking anything as common. So x square minus 4x plus 5, x square coefficient is already 1, so I need to take them together, the first two terms. Now I'll find the half of the coefficient of x, that is 2. So I will add the square of 2. Remember, you always add first and then you subtract. So it will be add the square of 2, subtract the square of 2 plus 5 at the end. If you have a look at the first three terms, these ones, the ones I highlighted, these are making the identity as x minus 2 whole square minus 4 plus 5. So the completed square form will be x minus 2 whole square plus 1. I emphasize again that the final answer should be in the same format as he is asking from you in the question. The last portion of the question says hence or otherwise. Hence means that it is related to the previous part that you have solved. Write down the coordinates of the minimum point on the curve. So minimum point, I told you earlier as well that minimum point means the coordinates of the turning point. So you can easily figure out the coordinates of the turning point or the minimum point, that is going to be 2 comma plus 1. Let's move forward. The next question, question number 7. Question number 7 is that there is a curve and there is a line. They are intersecting each other, and if you see, the diagram shows the curve y is equals to 7 square root of x, and the line, this is the curve, the first one, this is the curve that you have, and this is the line, y is equals to 6x plus k. Now he says that the curve and the line, they intersect. I told you, whenever you see the word intersect or meet, you are going to put both the equations simultaneously to each other. You are going to solve both the equations simultaneously to find the value of the intersection point. Now it says that for the case where k is equals to 2, find the point x coordinate of the point of intersection. The point of intersections are A and B. So as from the word it is clear, they are intersecting. I told you, put both the y's equal to each other. So the start of the question will be the same because of the word intersection. So we are going to put y's and y's equal to each other. It will be 7 square root of x, which will be equal to 6x plus k. Now we can simplify it as by taking square on both sides. It will be 49x equals to, I have to take the square of this complete term which is there on the right side. So if I take the square of the terms on the right side, remember the value of k is given to you for this question. So what we are going to do, we are going to replace this value of k as 2, and we are going to expand it. Now the expansion of this will be 36 x square plus 24x plus 4, and I'll bring 49 to the other side as well so that I can simplify it in the same steps. Remember, if you squeeze the number of steps which are irrelevant, it's going to be save a lot of time and you'll manage the questions really well. So it is going to be 36x square plus 24x minus 45 equals to 0. Now if I do the factorization for this, it will be minus 45. So I am having two values of x from here. They are 5 over 6. Yeah, the first value is 5 over 6, and the other value for x is minus 3 by 2. So these are the two values of x for where one of the point is going to be A and the other one is going to be B. So let me just have a look. It's 2, and I substituted the value of k as 2 over here. We took the square, 49, 6, 36x square, 12, 24. Square of 2 is 4. 49, it is 49x. This is not going to be the equation. It will be 24 minus 49, and the equation will be 36x square minus 25x plus 4. It will be equal to 0. Now if I find the factors for this, there was an error. Minus 25 plus 4. The two answers for the values of x, if I find out, they are going to be 4 over 9, and the other value for x will be 1 by 4. please be mindful that how to see if there is any incorrect answer. If you see over here, both values of x coordinates are supposed to be positive. So in case if you see there is a negative answer, you should know that the values that of x that you found out, they are not correct. Let's move forward. We already have the values of a and b. Let's see. Uh, this one is going to be a, and this one is going to be the x coordinate for b. Let's move forward. It says that find the value of k for which the line and the curve, they are tangent to each other. So again it's the same scenario, but now we need to find the value of k where the line and the curve, they are tangent. So I'm sure you must remember that whenever a line and the curve, they are tangent to each other, it means that b square minus 4ac, it will be equal to 0. But again, we are going to first see, we are going to solve the curve and the line simultaneously to find out equation for the intersection, and that will be 6x plus k, it will be equal to 7 square root of x. We'll take square on both sides, that will give me 36x square plus 12xk. Remember, I'm taking square on both sides. Let me write it here. I'm taking square on both sides to get rid of the square root symbol from the right side. Plus k square, it will be equal to 49x. So 36x square minus plus 12xk minus 49x plus k square, it will be equal to 0. Now since we know that the line and the curve, they are tangent to each other, so it means that b square minus 4ac, it will be equal to 0. The value of a is 36, the value of b is 12k minus 49, and the value of c is k square. Let's substitute the value here. It says 12k minus 49 whole square minus 4 times 36, c is k square, equal to 0. Now if I do the expansion, it will be 144 k square minus 1176k plus the square of 49, which is 2401, minus 4 times 36, which is again 144k square, and it will be equal to 0. Now 144k square and 144k square will cancel out. So we are going to be left with minus 1176k, and it will be equal to negative 2401. Negative and negative will cancel out, and k will be 2401 divided by 1176. So 2401 divided by 1176, simplified answer is 49 divided by 24. So the value of k is 49 divided by 24. So yeah, I hope the question is clear to you. Yeah, so you can even verify your answer by looking at the question as well, that the question is asking you for a value of k. So there has to be one specific answer for the value of k. Let's move forward. We'll see there are going to be scenarios in which he is going to ask you for the set of values of k, which means that the k or the alphabet, it is going to have a range of values, which means that you need to write your answer in inequality. It means that the answer is going to be in inequality form. Let's move to the next question, question number 8, which is from May June 2012. Paper 1-3. The equation of a line is this, where k is a constant, and the equation of the curve is this. So this is the curve and this is the line. In the case where k is equal to 8, the line intersects the curve and the curve at point A and B. So for the value of k, it is the line and the curve, they are intersecting each other at two different points. You need to find out the equation of the perpendicular bisector of AB. The first portion of the question is related to quadratics, but the second portion of the question is related to coordinate geometry. But we are going to do them both. Let's see. The value of k is given to us and the value of k is 8. So if we substitute, we know that we are going to solve both the equations simultaneously. So if we solve both of them simultaneously, what we can do is, it's 2y plus x equals to 8. This is the first equation. We can make x the subject from the second, and so it will be 2y plus 6 divided by y, it will be equal to 8. We can further simplify. 2y square plus 6 is equal to 8y. So 2y square minus 8y plus 6, it will be equal to 0. Simplified form will be minus 4y plus 3, it will be equal to 0. We can find the factors of these. It will be minus 3y minus 1y plus 3 equal to 0. So y minus 3 minus 1, y minus 3, it will be equal to 0. So we can find the value of y. The one value of y will be 3, the other value of y will be 1. So these are the values of y of the two respective points A and B, the intersection points A and B. So we can find the value of x coordinate as well by substituting it in the curve portion, which is 6 minus y. So if 6 divided by 3, this is going to be 2 for the first, and 6 divided by 1, which will be 6 for the other. So we have the two coordinates with us now. What are the two coordinates? A and B. Let me mark them both over here. For example, A is the first one, which is 2, 3, and B is the second one, which is 6, 1. Now let's go to up till here the question was related to quadratics. Now let's go to the second portion, which says that find the equation of the perpendicular bisector of the line AB. So perpendicular means that the gradient is going to be negative reciprocal of the gradient of AB. Bisector means you need to find out the midpoint from where the line is passing. So let's find out the midpoint so that we can have the coordinates of the point from where the line is passing. So midpoint of AB. So if you find the midpoint of AB, they will be 2 plus 6 divided by 2, which will be 4. 3 plus 1 divided by 2, which will be 2. So this 4, 2 are the coordinates of the point from where the line is passing. Now we need to know the gradient of the line AB. So gradient of AB. So gradient of AB will be 1 minus 3 divided by 6 minus 2. Minus 2 divided by 4. The gradient of the line AB is minus 1 by 2. But remember, the equation we need to find out is of the line perpendicular to the line AB. So the gradient of the perpendicular will be positive 2. It will be the negative reciprocal of the line AB. Now we have the coordinates, we have the gradient. We will use the equation of the line, which is y minus y1 equals x into x minus x1. we can use the coordinates from where the line is passing. The line is passing from 4 comma 2, so the value of y1 is 2, the gradient is 2, x minus the coordinate of x is 4, so y is equals to 2x minus 8 plus 2, and the equation of the line will be 2x minus 6. This is the equation of the line which is perpendicular, which is a perpendicular bisector of AB. I hope things are clear to you. Let's move forward. The second part says find the set of values of k, set of values. So it means that it is not going to be just one value for k, but it is going to be in inequality for which the line and the curve they intersect at two distinct points. So if the curve and the line they are having two distinct points, it means that the discriminant, which is 4b square minus 4ac, it will be greater than 0. Now again we are going to use the same scenario in which we will put both the equations equal to each other. So in fact what we can do is we know that y is equals to 6 over x, so we can substitute this value over here into the other one, which will give us 2y plus 6. We need to make x the subject. Even if you make y the subject, both ways the answer will be the same. It will be 6 divided by y, which will be equal to k. It will be 2y square plus 6 equals to ky, and it will be 2y square minus ky plus 6, and it will be equal to 0. Now we know that the line and the curve they are having two distinct points, which means that b square minus 4ac it will be greater to 0. So the value of b, it's minus k whole square minus 4 times 2 times 6, and it will be greater than 0. Now if I simplify, it will be k square minus 4 times 2, which is 48, greater than 0. Remember, we cannot, if I take the 48 to the other side, it is an inequality. We cannot take square root on both sides, like we used to do if there was an equal sign over here. So what we are going to do is we will make it in the form of a square minus b square. And how can we do that? It will be let me do it here in the open space. It will be k square minus square root of 48 whole square, because the square, ultimately the square and square root will cancel out, and it is ultimately 48. And if I write it is greater than 0, so since it looks like it is an identity over here, which is a square minus b square, I can write it as k minus square root of 48 bracket k plus square root of 48 greater than 0. Now the critical values of k, they are the critical values are negative, it is going to give you the critical values will be square root of 48, and the other value will be negative square root of 48. Now if I sketch the graph portion, the graph is going to look like this, and these are the critical points. One point is negative square root of 48, the other is square root of 48, and the inequality sign is of greater. So I told you that whenever you have the sign of greater, it means that the region of the graph is above the x-axis. So if the region above the x-axis is this region of the graph and this region of the graph. So for the left region, the answer is going to be less than minus square root of 48. This is less than negative square root of 48. And for the region on the right side, this is all the values on the x-axis, they are going to be greater than square root of 48. So it will be k greater than square root of 48. I hope the question is clear to you. You can even match it with the question that says that you need to find the set of values of k. Let's move forward to another question, question number 9. Question number 9 says that the line is this, where k is a constant, is tangent to the curve. So by tangent it means that the line and the curve, they are just intersecting at one single point, which is b square minus 4ac, it is equal to 0. You label that point, you are going to label that point as p. Find the value of k. Now it's simple. We are going to first solve both the equations simultaneously, and for that what we can do is we can make y the subject. For the first one, y is already the subject. X divided by k plus k, which will be equal to x square divided by 4. So if we further simplify, we can further simplify. It is going to be x square plus k square, it will be equal to kx square divided by 4. It will be 4x square plus minus kx square plus k square, and it will be equal to 0. Now if we further simplify, we know that the b square minus 4ac, it has to be equal to 0, because the line and the curve, they are tangent to each other. So if the line and the curve, they are tangent to each other, its b square minus 4ac discriminant will be 0. The value of a is, we have square for the first two terms. It will be x. Let me refix it. It will be 4x plus k square, 4k square, and it will be equal to kx square. Simplification, kx square minus 4x minus 4k square, it will be 0, and b square minus 4ac, it will also be equal to 0. The value of b is minus 4. 4 times a is k, and the value of c is 4k square, and it will be equal to 0. It will be 16, positive 16 k cube, it will be equal to 0. And if I simplify 16 k cube, it will be equal to negative 16. The k cube, it will be equal to negative 1, and the value of k will be negative 1. We can find the cube root on both sides. This is the value of k. For the next part, it says that the coordinates of p. We know that the value of k is negative 1. So if I substitute the value of k as negative 1 into the above equation, it will give me negative x negative 1. This will be the equation of the line, and the equation of the curve is going to be the same, which will be y is equals to x square divided by 4. Now if you go back and read the question again, it says that the line and the curve, they are tangent to each other, they are intersecting, and that specific point is known as P. Now we are going to solve them simultaneously, which will give me minus x minus 1 equal to x square divided by 4. So negative 4x negative 4 equals to x square. Equation will become 4x plus 4 equal to 0. We'll simplify. This becomes x square plus 2x plus 2x plus 4, which will be equal to 0. The two brackets will be x plus 2 and plus 2 x plus 2 equal to 0. Yeah, so there will be two brackets, and both the brackets will be, both the factors will be x plus 2. So we are going to get just one value of x, where the line and the curve, they are intersecting, and it was even mentioned in the question that the line and the curve, they are just intersecting at a single point, which is known as the tangent. So the x coordinate of the intersection, or the x coordinate of point P, is minus 2. Now we can find the value for y as well, which will be minus 2 whole square divided by 4, which will give me 1. So what are the coordinates for the point P? Let me write them here. It will be minus 2 comma 1. I hope the question is pretty much clear to you all. If there is any query, any question, please leave that in the comment section. Now after this, from question 10, we are going to do that in the next video. Thank you.